All right. Is my sound coming properly?
Yeah,
Okay, cool.
it's live.
Maybe.
Sadly, I have to go at 7, so we might need to cut this short, or we might not be able to go through everything we want to, but we can continue this at another time.
So everything will be recorded at least.
Yeah, so we're streaming, so everything will be live, and we can share the video with everyone as well afterwards.
Okay, that's great.
I'll invite everyone back to this link. Just start from the start. Give a very quick overview of what you did before, and then we'll jump right in again.
Sure, let's do that. When you start Unity, having a project, this will be a similar view that you're going to see. I have many projects that I've used, but ideally, if you're opening it up for the first time, there'll be none. So what you want to do is create a new project and make sure the 3D, you can give it any name, a tutorial, and then pick the location that you want to save the project in. It is important to remember where you saved the project, because if you want to share it afterwards, you'll have to dig it in. So make sure and create your project. Just create project depending on or how big the it might take up to a minute for Unity set up the project. When the project is set up, this will be the view that you're seeing. Is my screen shared properly? No. Okay. Yeah, cool. You'll be seeing. So let's work on this layout, and let's see how everything works. Also, please go to the Google Drive. I'm going to send the link in the chat right now. So I'll be taking notes as we go, and you'll be able to, if I mention a hotkey, for example, it will be easier for you guys to remember. So no need to change the layout. Okay, so let's start. So the area in the middle is called the scene view, and that is pretty much where everything happens. You can move around in space, and I'll talk about how to do so. And you can manipulate objects in the scene view. So if you have a cube, you can rotate it, change it, move it, and all of these things are done in the scene view. The second important view is the game one. Game view is basically what your player sees. Unity game or Unity scene, there's a main camera. There's the main camera. And what the main camera sees is basically what your player sees. And we'll talk about that. But if you switch to the game mode, you'll basically, game view, you'll basically have a taste of what your player is going to see. On that note, if you look to the left and make sure the untitled is dropped down, the drop-down menu is open, you can see a list of all the game objects that are in the scene. Unity uses a game object component system. Every single thing that exists in your scene is called a game object. So the camera is a game object, the light is a game object, the cube is a game object. Everything you add here everything you add to your game will be listed under your game objects, under the hierarchy view. So if you click on one of the game objects, a detailed view of what it is and what it does can be found to the right in the inspector view. So this area is called inspector. And each of these individual components. So let's say we're looking at the main camera as a transform component, has a camera component, etc., etc. One thing to know is that every game object has a transform component, and additional different components. So if we compare the cube component to the directional light, for example, we can see that there are different things. In the cube, there's the transform collider, which discusses or helps you understand where the borders of the bomb. There's a mesh. It talks about how light and visuals of the rendered. And if you go to the light, there's no collider, there's no render, because with anything, but instead it has a light component. In this case, it talks about what the color of the light is. And if I change this, that the stuff that in my scene is also changing. If I make the light red, then everything that the light shines on becomes red. Right. So basically, this is the overall view of how Unity breaks down its items. One final view is down below. This is the project area, and this basically is your file explorer. So if you right-click and show an explorer, it will basically bring up the folder that you save stuff in. So if you want to import scripts, images, models, or anything else, really, you will be putting it in here. Any questions up until this point? So yeah, please just reach out if anything is unclear or if I went ahead too fast. If there are no questions, let's start doing stuff and see how to play. Okay. So the first thing you want to do is go to Game Object, go to 3D, and then select a cube. So I'll be writing these notes in the Google Drive, so it will be easier to remember. So Game Object, 3D object, and then cube. Okay. So what this does is it initializes a cube. A cube in Unity terms is a primitive game object. So it's a simple one. So let's see how to move around in this space in relative to the cube, and how to move the cube itself. Okay. So on the top left, you can see that there are 5 buttons: the hand button, the movement button, the rotation button, the scaling button, and the UI button. So let's go one by one. If the hand button is selected, or you press Q, the shortcut is Q, you can click your left mouse button and move around in the scene. Can you guys give me 1 minute? Let me do something to help us out. Key, here. Okay, great. So now when I click something, you should be able to see what I'm clicking. So I'm holding the left mouse button down, and I'm just dragging the scene around. This is one way to move. If I press Alt and I press my left mouse button and move around, this allows me to rotate around the object. So just clicking moves up and down, left and right, panning. With Alt, it allows me to rotate. I want to go in and out, I can use the mouse wheel. One type of movements that you can utilize. Another way that I prefer is using a more first-person shooter game-like style. If you click the right mouse button, you can basically look around as if you're in a game. The camera will follow your mouse movement. In addition to that, while the right mouse button is clicked, if you press WASD, you can move around as if you're in a video game. So W goes forward, S goes back, A goes left, and D goes right. And using these, you can basically fly around. Q and E, while pressing the right mouse button, allows you to go up and down. All right, any questions? No. So just try familiarizing yourself with the movement. Try rotating around the cube, looking at it, and select your preferred way to move. It might feel clunky at first, because it is. The more you spend time with it, the easier it will become. So let me just type those in to our Google Drive movement. Press right mouse button, and on top of that, W forward, S backwards, A left, E right, Q up, I think. Up or down? Q is down. Q is down, and E. Or you can always mouse wheel to zoom in and out, and also press Alt and mouse button to rotate, mouse to look around. Okay. Press Q to pan around. Okay, so hopefully we can move around in the space now. So let's see how we can move the object in relation to the other things. So up until this point, do we have any questions? Okay, let's move on then. If you press W and click an object, you will see arrows, blue and one green. These represent the XYZ axes. Red represents the X one, the Y-axis, and blue represents the, and you can remember the ordering from RGB. Red, green, blue, X, Y, Z. If I click on any of the axes and move around, then the object that is selected will move on that axis and on that axis only. So if you look at the position value of X under the transform, right now you see that it is, or we can set it to 0, 0, 0. And if I move it in the X-axis, you can see that the position is only changing in the X. And as you could have guessed, the same thing goes for the other values as well. This is how you move an object, basically. There are also ways to move around an object in the particular plane. So if I click this square, the red square is in the X plane, which means the YZ. You can move around in the plane, but I don't think that's that useful. The third way to move around an object is basically the position of that object specifically. So if I want to put this guy in 0, 0, 0, or if I want to put this guy in -1 or -10, 0, 0, that's also a possibility. So the shortcut for this is W. If you want to rotate an object, you press E, and then you get a similar gizmo. There are 3 lines, the red one, the blue one, green one. And guess if you click on any of those, you can rotate on that specific axis. If I click on the red one, you can see that on top right here, the X value is changing. On that note, you can rotate it on Y, and you can rotate it on Z. Pressing E gives us the rotation. Rotation is given to us by E. And scaling is the R. So if you press R and click on an object, you will be in scaling mode, and this allows you to change the size. There are 4 different cubes that you can see. The colors once again correspond to X, Y, and Z. If you click one of the colored ones, you will be manipulating the object in that axis only. So stretching in Z, stretching it in etc. If you click on the middle one that is gray, it will basically preserve the proportions and increase the object in scale. So these are the main tools that we use to move around objects, change the size, and manipulate the scene. Take note, rotation, and scaling. It's fine. So any questions up until this point? No? Okay. So now we will start by looking at how components work on game objects. We have been doing stuff, moving around objects, but we have never actually tested in the game. What happens, see how our players would interact with this. So in order to do that, you need to click the play button. Button, you will basically see through the eyes of the camera, and the player will see what's going to happen. And right now, nothing is happening because we have a cube or a rectangle at this point, and that is pretty much it. So let's add some gravity to our cube. Before we move on, let's make sure that it's pointing to the way that we want it to. So when you click your camera, bottom right of the scene view, you can actually see the camera preview. And I move the camera closer, the camera preview will change. And you can basically manipulate the camera just like any other object. You can rotate it, fill it. No, you cannot fill it, but you can move it around. And this allows you to put the camera wherever you want it to. But I personally feel that that sort of adjusting is a bit clunky. So the way I prefer to do it is I basically move my camera the way I want to. So I want to see this rectangle from the side. And then I click on my main camera, game object, alignment view. So right now, take a look at the camera preview. Right now, the camera is looking at it from this side. And when I press align with view, what will happen is my camera will pretty much jump position, which will allow it to look same frame that I'm looking at right now. So let's see. Yeah. So my scene view and my game view is now perfectly aligned, and this makes it really, really easy to align your camera. Let me just add that as notes. The camera from hierarchy. First, you need to move your scene view to your preferred perspective and select the camera from the hierarchy and press game object tab and then press align. So let's go back to adding some components to our game. Whoa, what is happening? There's something weird happening. So now, if I want this cube to fall, see, I have to change something with it. And the way we change stuff is by adding new components. So most simple component or the most useful, one of the things that one of the most useful ones is rigid body. So I want you guys to yourself a cube, a sphere, whatever game object you want, and then add a rigid body. And the way you add the rigid body is rigid body. Select your game object. In this case, cube or sphere or whatever you want it to have. Add, go to add component or click to add component in the inspector. And then add a rigid body. Make sure it is not rigid body 2D. Make sure to have it as 3D. Okay. And rigid body basically allows objects to interact with the physics. Rigid body, and as you can see, there's the use gravity button is ticked. Click. So if I press start, unlike the earlier version, now my cube is going to fall because it's interacting with gravity. Using this, let's create a domino game. I like doing this because it forces you to use all the tools you learned. What do I mean by the domino game? So let's create a base that our objects are going to fall on. So if I create a base that my object is going to fall on, and I press start, then the object is just going to plop and stay there. And the fall because it does not have a rigid body object attached to it. So it's not necessarily interacting with gravity. Let's see if this works properly. Looks okay. So what I want you guys to do is create a little domino game. And I'll tell you what I mean by that in a second. So just have an inclined plane, have a huge box, rotate it such that it's inclined, put it down.
Sorry, Batu, can you share your screen, please?
Sorry? Oh, the screen sharing died down. Okay, gotcha. Is it good now? Can you guys see it? Okay, so what I'm doing right now is I've created a cube. It should not have a rigid body because we don't want it to fall. I've created a floor. No rigid body once again because we don't want it to fall. Which will hopefully fall onto my cube and then bounce back. And then now I'm going to create the dominoes. So at this point, if we want to see how the game plays, you can press start. The sphere with the rigid body falls, hits the inclined cube, and starts rolling to the side. And now I just need a few domino pieces for them to interact in an interesting way. I just move my cube, scale it so that it kind of looks like a domino, and I add my rigid body. And because I want, yeah. And let's see if this works. The ball falls and misses the domino completely. So let's just scale it so it's bigger. Try it again. Ball falls, hits the cube, and the domino falls. Okay, so I'll wait a few minutes for you guys to get to this stage. I think doing this is important because it really forces you to manipulate the scene, objects, the rotation, the size, know which objects to add the rigid body, and also positioning the camera. So please let me know if you need any help at any step. You can share your screen and we can take a look at what step you're at. So any questions? So after we're done with this, this will finish our basic introduction to how Unity works and Unity components. Usually I spend a bit more time in going to, actually, yeah, before we move on, we should do one more thing that will become important. We'll be talking about parenting and combining different objects into one bigger object. And after that, we can switch to Sphyria, and I can walk you guys through at each step to show you what's happening, and we can have a basic understanding of how the Unity project is set up. Okay, so if you guys feel comfortable, we can, should we move on? Anyone who needs more time, just type it in the chat. Otherwise, I'll just move on.
Yeah, Batu, I think you should move on. And this is all will be on YouTube afterwards, so people can go through it again after, step by step. I know your time is limited as well, so let's just move on. And your screen is not shared, so it switches off.
Yeah, it sometimes switches off. Okay. Yeah, please let me know when the screen sharing just dies down. Okay, let's go back to work. So it's nice to be working with these kind of individual components, but they don't necessarily make sense when you're trying to build something that is more complicated. So let's say if we are trying to build a human representation, we would, you don't have to do this. I'll just do it as an example. We can have a sphere as a head, and then maybe this. Then we can have some arms. Right. Like this. Those are small arms. And let's have two legs that are similar. Yeah, that is a great representation of a human, but it's good enough. Good. Right, so that is our human. And if we want this guy to interact with gravity, what we can do is we can basically add rigid bodies all over, as we did before. And let's position our camera to look at this dude. 1, 2. And if you press start, what will happen is not probably what you would expect. The person or the guy that we just created exploded. And the reason for that is when we added rigid bodies to each individual component, we did not tell Unity that this was an object as a whole. And as in real life, objects do not merge into each other. So when this object is overlapping with this object, torso and arms, Unity basically freaks out, saying that, oh no, this is how not matter in space works. I really need to make sure that these do not coexist on the same physical space. So it ends up basically exploding, as you can see right here. So what we need to do is, instead of adding rigid bodies to individual components, we need to make sure that Unity understands that this whole thing is one single object, or Unity should treat it as one single object. So what we can do at that point is we can create an empty game object. As you can see, there's nothing in it. It's just a transform. It's just a location. And give it a name, for example, human. And then add all of our spheres, all of our individual components into that human. And now, if we press start, nothing is going to happen. Well, our camera has moved back. Let's move the camera to the correct place once again. If we press start, we forgot to remove the rigid body from the head. Let's do that. Okay. I removed all the rigid bodies from the individual components. And now if we press start, nothing is going to happen. instead of adding the rigid bodies to the individual components, what I will do is adding a rigid body to the human. So now, if we press start, the human as a whole will fall, and it will not result in a huge, weird explosion. Yeah. So you might be curious about the green lines. Those green lines are basically the colliders of the spheres. Don't worry about them. And going forward, if we go into more detail, we can talk about them in depth. So this parenting versus parenting groups of objects is important because you will see that in our Sphyria project there's a lot of hierarchical parenting. There will be a camera, and under the camera there will be the left eye and the right eye. Under that there will be additional components. So it's good to understand how this parenting works. So anything that you add to the parent also applies to the children. So if I move the parent, whether it via script or via the scene view, everything you see on the screen will change. Okay, so let's jump into the Sphyria project. Sphyria, yeah. I don't want to save. While that opens, I can give you the link for the Sphyria. Right now, you don't have to download it, but it's on GitHub. It is not the latest version. I will probably update. I'll update the GitHub soon enough. I made some changes, but this is as close as we get from the most recent version. I'm going to send it in the chat, and also I'm going to put it on the top of the Unity Sphyria tutorial. For parenting, remove groups of game objects. Later, Facebook later. Okay, so this is Sphyria, and the way I prefer to use Unity is screen sharing still working. Let's check. Okay, it's going on. So it's the same scene, same windows, but they're aligned a bit differently. So on the top left, you guys can see the scene view that we've been doing our job in. The game view is basically what the hierarchy is, as you guess, what we had, the list of objects that we have. And for example, in here, there's this map object, and under the map, they're like map 1, 2, 3, 4, 5, 6. Or in the spheres, there's the test sphere, there's the sound, there's a location, etc., etc. That's why understanding how parenting works is important. This is the project view. This is a much more full project, so you can see that there are different images, our scripts, our scenes, and as you can see, this is the inspector. Okay, so let's just play the demo, and I'll talk about what's happening. So when we play the demo, we start by looking at the scene, then we start moving around, and at this point, we're using the Google Cardboard API, which allows us to simulate virtual reality or create virtual reality applications. We slide down, left mouse button, you move forward in that direction. And if you click on a sphere, you jump in. Oh, that is a bug we should fix. Great demo, guys. I'm glad this did not happen while we were presenting it at stage. But basically, as you guys remember, if you click on something, you just jump into the sphere and you look around. Okay. So let's break this down. So let's talk about what's happening. You can remember what we're seeing is what the main camera sees. So when you see the camera moving on the top right, or the perspective moving, what actually happens is the main camera moving through space. And we do that by using a script. So I think the script that we use, I don't remember which script makes the camera move, but if you look to the right, you can see that there are numerous scripts that are attached. So let's take a look at the mover script. Or before we do that, let's talk about what scripts are. Scripts are pieces of code that act on the game object. And you can have more than one script. And these are the scripts either that we as a team wrote in the machine learning, or not machine learning, media lab session, or the scripts that are given to us by the API. So because we are using the Google Cardboard code that those guys, well, Google wrote, and instead of rewriting all that code, we basically download it and attach it to our object. If you want to attach code to any object, it is very simple. You just click and drag, and whatever is within the code executes whenever you play the scene. So let's start by taking a look at one of the codes to see. I think movement code is a good example. It will give us an idea of how code and Unity plays well with each other. Okay, if you double click on any script, Unity will try to open it in your preferred text editor. In this case, it is Visual Studio, but you're more than welcome to use anything else if you have a preferred text editor. Okay. Let me just turn this keycaster off. I don't really need it anymore. Yeah. Okay. So our mover script is this, and it allows us to move around in space. Let's just look at a specific part of the script. Is there anyone who is not who has not coded or who's not familiar with any type of code at all? If that's the case, I will explain things in more detail. Anyone? Okay, I'll just assume some level of code literacy. In Unity scripts, we usually use two functions as our basis. One is the start function, and the other one is the update function. What start function does is it executes once when the scene is played. So if we print hello Sphyria, and when we start our game, we will see that printed in our console. My console view is not here. Where did my console go? Window. When I change the layout, there we go. Okay, console. There we go. When I change the layout, some of the windows just disappeared. But console is basically where you can print and look at stuff. And as you guys can guess, when I wrote print hello Sphyria, and when I started the scene, the start function executed, and the result was printed to the console. Unlike start, update function is called every single frame. So if you want something to happen periodically or very, very fast, you write it under the update function. So if I create a counter and then print the number of the counter or print the counter, and before printing, update the counter so that counter is counter +1. What we will see is basically the numbers to counter increasing very, very fast. Let's see. Yeah, as you can see, the counter is increasing drastically. So those are the two main things that we use when we're writing code in the start and the update function. Another thing that we use is how to get inputs. So there's this concept of input get key down. So on rough terms, basically, it allows us to check for inputs. So if I say input.getKey, let's say U, this basically means that whenever the key U is pressed, execute code that is here. U is pressed. If I run this, basically, we will not see U is pressed until I press U. And there we go. And this is basically how we implemented the movement functions. So we basically added some keys. So instead of U, right now it is space. And in here, we basically change some stuff wherever space is pressed. And this is going into a bit too much detail. We don't have to go line by line. But on the highest level, basically we catch the input. And whenever that button is pressed, we execute the desired code. So let's look at what's happening on the highest level. So that's how the movement is done in Sphyria. After that, we have a few other different pieces of code that is of interest. We can look around, and when we reach here, move, and if we press on one of the cubes, we will just jump into the cube and we can look around. And also, there should be some sparkly bits that start the player. So let's talk about jumping in and out of the cube. That piece of code is in gaze, I think. Correct me if I'm wrong. Yeah, Gabe. Okay. So what happens is basically when you're close to a cube, Unity understands that you're close and it changes the way the reticle moves. So right now I'm looking at a sphere, but the reticle is small because it's a bit too far and it's beyond our limit, the distance. And if I'm looking at the cube that is nearby, the reticle changes because Unity understands that the direction I'm looking at is crossed by a cube. And that code is under the gaze script. Right now, I don't have much time. We have 10 more minutes left, so I will not go into the detail, but explain what our functions do. So if you decide to move on with the development of this project, you can have an understanding of how the different moving pieces fit together. Whenever I click while I am looking at a sphere that is nearby, I jump into it. And the way that is done is basically pretty straightforward. First, you you save where your location is so that when you want to go out of the cube, you can actually return there. So when you click, what happens is instead of moving forward, you get teleported to the center of the cube. And if we try moving around, that is not possible. So we teleport you to the center of the cube, we disable the movement, and we allow you to look around. When you look to the ground and click on the red button, basically it's the same thing, but instead of moving you inside of the cube, we move you outside of the cube where we stored the your earlier position. So let's just look at that on code. So enter sphere is what happens when we click on the cube. Here you can see that we are storing the enter position and enter rotation. We will be returning to these when we exit. And what this line means, transform.position, is basically getting the component and then the field in that component. So what does that mean? The code that we're looking at here, gaze, is attached to the main camera. So when I say transform, what happens is the code basically goes to this game object and goes to the transform component. And if you guys can remember, the transform component deals with the position and the rotation of our objects. So then inside the transform component, we want to get the position. And we basically, inside the transform component, we get the position. And just like the position, we get the rotation. Transform position and transform rotation. And that's basically what it means to have the transform position and transform rotation. And after that, here, we basically check, what is there something called? We basically check if we hit a photosphere. In this line, we check whether we hit any object. And if that object is a photosphere, we basically move ourselves in it. Where do we do that? At this point, I don't remember, but that's what happens. And if we want to exit the sphere, we basically, whenever we hit the red part in our sphere, the other part plays. So instead of entering, we exit the sphere. So yeah, we are playing this, we're running this function. So I'm just keeping it high level, but if you're interested, we can sit down and learn more about the project. And when we change code while the game is in play view, it crashes. So not that good, don't do that. And we now know how to move around in the space, or how Sphyria moves around in space. Now we go jump in and out of the cubes. And I guess the final thing that we can mention is the start, how we start from here and make this motion. Basically, what happens is very simple. Of 4 seconds, and after the delay ends, position, we have an ending position, and we smoothly transition from initial position to our final position by using a function called lerp. And if you're interested in learning more of that, you can find that in Google, because I don't necessarily know the details of how that function executes, and I sadly don't have much time. I think that can bring us to a conclusion about how Unity on the most high-level work, and also how we have created Sphyria on the few moving parts. So we can talk about having a further session next week in which we can go deeper into the specific code pieces, or how these spheres are created, how we get the map. I guess we can send out an email and see if there's any interest. So at this point, do you guys have any questions or anything that you would like me to explore more, discuss more? Fire away.
Yeah, thanks a lot, Batu. I think this was a really good overview of Unity, and just a sneak peek into Sphyria. We'll check with everyone else and see if, especially for those who want to continue working with us on it.
Yes.
We will share. We will be more in touch about Sphyria and what we can do. Thanks so much for your time. I'm gonna stop the broadcast here, and thanks everyone for showing up, and hope this was helpful.
Yeah, thanks for listening, and I really hope that was helpful. See you guys around.
All right.
Bye-bye.
Bye-bye.